Hi, I'm Varun, and today I'm going to give you a small brief idea about my platform, which is AccessNotes. So, AccessNotes is basically a platform where professors can upload all of their handwritten notes, which they do in class, and it gets converted into a accessible HTML document which is accessible to any and all students and is compliant with federal law. So this is basically like the teacher dashboard where they can create a given class, and then with the class code, for example, I have math 22A, math 21B, ENG 108. So for now I have a class called test 44V. So the teacher can create a class, they can go and enter this class, and here's where the magic happens. They enter the title for the lecture. Let me say this is lecture 01 on integration, and they can go ahead and choose the date of when this class was taken, just for like filtering purposes. And then they can upload a document. They can basically upload the notes from that given class. So let's say I take lecture notes C04. It would look something like this. So these are the notes of the class. You can see the professor has written a lot of notes in his handwriting over here. This is in the inaccessible format, which means it's not compliant with federal law as of now. So if a professor were to upload this document, it is not compliant with federal law and he may face lawsuits. So I'm going to upload this document here, and over here I can choose with this particular document is available to students from which university, UC Davis, UC Berkeley, and so on. So I'm going to upload this document over here, and while this uploads we can just wait for a bit. Okay, so now that we have our entire document ready, it's passed all the accessibility checks here within the pipeline, and it's now ready to publish, and any students can access this. So I'm going to click on review, and then I'm going to now publish these. So the moment the professor clicks on this publish now button, this particular document is now accessible to any and all students who have this given link. And once I click on this, it opens up this entire document on a publicly accessible URL, and it's all in the accessible format given over here. As you can see here, these notes given here are exactly the same as what the professor has written in his original document. As you can see, it's all given accurately over here of a given graph. The whole graph is also mentioned here. All of his notes, as you can see, this p is equal to open bracket x0, x1, x2, all the way up to xk, xn minus 1, xn. Every single one of these is come out exactly how the professor has written it over here in his own handwriting. And mind you, the professor says that this is some of his worst handwriting, so it's really able to recognize all of this with complete and total accuracy as it's given here. You can see sigma is integration, ck is x, and delta xk is in fact dx. So this is just very accurate. And let me get to the most interesting part, which is the read aloud. So this entire accessibility reader that is given over here, and just let's see how it reads everything. So if I click on this, it's going to have an on-screen accessibility reader read it out.
The sum from k equals 1 to n of f of open paren c sub k close paren normal triangle x sub k right double arrow the integral from a to b of f of x dx. More specific.
So this is exactly how a given accessibility reader is supposed to read this. And let me show you an example on something else here.
Recall the general definition. The integral from a to b of f of x dx is identical to lim over the metric of p right arrow 0 of the sum from k equals 1 to n of f of open paren c sub k close paren normal triangle x sub k period. When we use equally spaced subintervals, illustrated on the number line below.
So I can do all of these accessibility features.
Powered by a equals x underscore.
That have been given below. I can change the speed of how fast the narrator talks. Like for example,
equally spaced means each subinterval has the same width. Normal triangle x equals the fraction with numerator b minus a and denominator n. The partition points are then given explicitly by x sub 0 equals a comma x sub 1 equals a plus normal triangle x comma x sub 2 equals a plus 2 normal.
So as you can see, this is completely compliant with federal law and in an accessible format as required. And it's really, the professors really like this given product. try this over anything else.
Theorem. If a function f is continuous over the interval open bracket a comma b close bracket, or if f has at most finitely many jump discontinuities, then the definite integral. Theorem.
So yeah,
If a function f.
that's pretty much what it is. This is incredibly accurate, especially the whole text recognition. I'm working on making this better. And then if I go back here and let's say I sign out and I sign in as a student. So in the student view, this is exactly what a student would see. I have been added to this class where I'm a UCD as a student, and I can go to the directory and click on any one of these lectures, and then I get the exact same view with this accessibility reader with all of these graphs generated for me over here. This is the student. So that's pretty much what I've been working on, and it's working out really well so far.